Let's keep going. We just finished drawing our 3 different types of squares that we use. These are located in the front of the shop, and you're welcome to use them as needed. That's what they're there for. Now, what does tolerance mean? Tolerance means the amount of allowable error. The amount of allowable error. Okay, so for example, here we have this block of wood. How far out can I be from square and still have it be within tolerance? Meaning, how much error, how many degrees out can it still be and still be okay? Because perfection is very difficult to attain in this life. So I will tell you, number 7, what's tolerance when using a square on a small block of wood? We should be able to put this on here and not see any deviation from the square. So, for example, I'm looking at that blade in relationship to the block of wood, and it is tight. Okay, so that's really good. We would call that square. It's 90 degrees. Now, is it perfect? So what's the tolerance? Nothing. Is 0. Shouldn't be any problem at all. Now let me give you another example. This side that looks square, but can you see that gap? That's about a degree off, and that is not tolerable. So there's a gappy right there. So you shouldn't see any amount of smallness, even on this one, okay? If we were to extend this out a long ways, we might eventually see a gap because it's probably not perfect. But on this small amount, it should look like it is. So now we're going to do a little exercise. Number 8 says to check for square on a small board. We're going to use this small engineer square, and we're going to look at all of these angles. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 corners, and see if we can't see what's square or not. I'm going to put an X on the ones that are not 90 degrees. Okay? So that one looks good. And I'm assuming then that this one is good, and it is. I'm going to look at that one, and it is, can you see? That's bad. And I'm guessing that then this one is also going to be bad, which it is. Now I'm going to check that one. That looks pretty good. This one also looks pretty good. That one looks pretty good. That one looks good. Now I'm going to check these. That looks good. Wow, this one's way out. Whoa. Thing is way out of there. You see that bad? Super bad. Guessing this one is going to be that way also. And you see that gappy? Pretty bad. That one looks good. Okay, so of these, this one is out of sides out of square, and this one's been cut out of square. So on your worksheet it says how many angles are not square? 4. 4 of them are bad. Okay. So the consequence of this is when I go to try to join something to it, like if I was to join this bad piece to another piece next to it, it would look like this. And it wouldn't lay flat because that is angled and not square. That's no good, right? When I take this guy, this frame, which is a nightstand frame, and I put him into there, this joint has to be square, otherwise it doesn't sit right. Okay, so this is a review number 9. What are the 6 steps to squaring a board? That's pagitum. So I want you to write down planer, planer, joiner, table saw, miter saw, miter saw. Pagitum. Okay, now let's talk about bigger stuff. Once you understand how to check for square on something small, let's go to something bigger. And I'm going to use this as our example. And this is a blanket chest panel. Now, we got a couple of options here to check for square. One is to put a large framing square on it and see if it's square, which you can see right now that it's not. There's also another option, and that's using a tape measure. So there's also a method to find out for square with the tape. So on your sheet, I'm going to say how to check for square. One is to use the framing square. The second way is to use geometry. And to do that, we're going to do it with our tape measure. Keep writing to write geometry. Use a tape measure. I need to check the length of that, the length of that, and make sure they're equal. The same thing with that, and the same thing with that. Then I need to check AD and BC and make sure they're equal. So AB should equal CD, AC equals BD, and you should be writing this on your paper. And then the diagonals should also be equal. Okay, that's how we use a tape measure to see if it's right. Now, number 11 says, what is the tolerance when measuring the diagonals? This tolerance is a little bit bigger and harder to achieve, and so your tolerance is a 1/16. That means if I measure across the diameter of this, they should be the same. And within 1/16 of an inch. And then number 12 is a little exercise to help us do that. So here's an example. I'm going to do this one, and let's do it together. So I'm going to check AB first. And that is 18 1/16. You do it with me. Then I measure the bottom. 18 1/16. That's good, right? So far we're looking pretty square. Now the sides. (19 13/16). This guy is 19 and 15/16. So I already know that something's going to go off here because I'm 1/8 of an inch out of square from AC to BD. So let's check the diagonals now and see what they look like. This measures 26 7/8. And then this diagonal measures 26 11/16. A difference there of 3/16 of an inch. We would call that 3/16 out of square. That's no good, right? Our tolerance is 1/16. So that tells us that something is wrong with this panel. It's not square. And it looks like it's sitting a bit skewed. It is probably either a parallelogram or a trapezoid. So we got to fix this. There are 6 steps to squaring a large frame. And that's what I want to review with you now. So just like a board, we legitim, a frame, we have to square also to get it into true. And you would think that it would be square already, but it's not. If that's not exactly the same as that, if that's not exactly the same as that, and when they were glued together, if they weren't done perfectly square, it's not. And that's pretty common. So we are going to then do this. Instead of planing it, we're not going to plane it because we have cross grain situations. We are going to sand it. So we wide belt sand one face. We wide belt sand the second face. Third, we're going to do an edge, and we can joint that just like we do a board. So we're going to joint, use the joiner on that. On the other side, then the other edge, just like a board, we're going to use the table saw. And then on the ends, normally we would use a miter saw to cut the end. That's too big for the miter saw. So we're going to use the panel saw. And for the feet, we'll do the same thing on the panel saw. So what do we call this? Widgetup. WWJTPP. Widgetup. Here we have Pudgetum. Here we have Widgetup. That's to make a panel square and nice. I believe we're done with this worksheet. If you were here, I'd be having you measure your own panels and see how they're looking. You'll all get a chance to do this with your work in one of the procedures.